Now let's try to focus our thing on Scala, right? Or learning on Scala. So why Scala? As I mentioned, the power of Spark basically comes from Scala language. Okay. So now why Scala? So Scala, will in the same way, let's look at Scala. So Scala is a general purpose programming language, okay, which was sort of conceived as a next generation of Java, right? Now, when we talk about Java, see, Java is an object-oriented programming language. But when you talk of Java, so Java is just not the language, right? So the Java technology stack consists of at least three components, right? So there is the Java runtime environment, okay, or the JRE, or what we call as a Java virtual machine, right? So in the Java paradigm, you build an application and you execute this application on a Java runtime environment. So you're not executing this application on the native operating system. Okay, so your native operating system could be Linux, Windows, Macintosh, whatever it be, right? Now, if you were to build an application that executes on the native machine, which means if it is built for Windows, it will not work on Macintosh, or it won't work on Linux, right? Whereas Java, if you looked at the pre-Java world, most of the time, again, there you are always porting from one operating system. See, not only are you porting the data from one database or one form to another form, you are porting your applications from one operating system to another operating system and so on. Right? So it's a hell of a lot of maintenance work, right? But Java solved the problem by the way of having a runtime environment, which when you install Java on a machine, so basically you're installing the Java runtime environment. So the Java applications that you write is executed on the runtime environment, right? So Java's runtime environment takes care of executing the code. So when you write an application using Java code, so the compiler compiles the code into a Java bytecode, and this bytecode executes itself on the Java runtime environment. So therefore, it is independent of the operating system. So it is highly interoperable, right? Now, this part of it works very well, extensively tested, and it is accepted everywhere, right? So it's pretty much so. Therefore, the Java is now available on billions and billions of machines, right? Now, the design philosophy of Scala, so Martin Odensky and his team basically created, Scala. So the idea was to leverage on the best features of the Java technology stack, but address the problem within the Java technology stack. The weakest part or the weakest link was basically the language, right? So Java language, was a low-level language, and it required a lot of boilerplate code, creating the variables, defining the methods, writing the getters and setters and so on, right? So a whole lot of code has to be written. So for every member variables within a class, you have to have some getter setters and so and things like that, right? So a whole lot of time is spent on basically the structure of Java language, right? So which means that you have to write a lot of lines of code, and the possibility of having errors are also higher when the programmer has to write too many things, right? Now, this is the problem they try to solve, and not only that, see the another especially after the emergence of Hadoop and this distributed processing, now to implement solutions in a distributed world, okay, where you are dividing an application or a job into multiple tasks and executing it on a different machines. Okay, now this requires a different way of thinking. So no longer are you thinking sequentially. Now you have to think parallelly, right? So in a parallel processing approach, okay, certain other way of working actually suits more, right? We are talking about functional programming languages, right? So now Java does not have a support for functional programming language, right? And also Java is not a pure object-oriented programming language, because in Java, besides supporting object orientation, okay, Java also has the data types which are implemented as which are primitives, right? So these are like the first-class citizens in a Java program, right? So where you have different primitives like integers, data types like integers, characters, floats and doubles and so on, right? Now these are not objects; these are data types, right? Now, um, and also there is no support for functional programming. Now, with the advent of distributed processing, now there was there was a relook at why not use the functional programming features, okay, which is more suitable for doing parallel processing, right? So you can think of functional programming as as a way in which you treat the functions as first-class citizens within your programming paradigm. Okay, so what I mean by functions as first-class citizens is simply that you can do with functions whatever that you can do with data types, right? So, for example, um, you can use, I mean, what can you do with data types, right? So you can assign a data, a data to a data type, right? So similarly, you can, you can assign a variable to a data type, right? So similarly, you can assign a function to a variable, right? So you can assign a function to a variable, and then you can pass a data type as a parameter to a function, right? And similarly, you can think of a function being passed as a parameter to another function, okay? Or like you can return a data type, right, from a function. So similarly, you can return a function as a return value from a function. Okay. Now, this requires a different way of thinking altogether. So don't worry if this doesn't cut. I mean that it doesn't bring anything to your imagination. We will look at these features in depth, right? So basically, the point I'm trying to make here is the functional programming features allows you to pass functions as arguments to other functions. Okay, now this comes very handy when we are talking about distributed processing, because you could now think of passing functions as arguments to functions where since the the job is split into multiple tasks and these tasks are getting executed on different machines, so you can simply pass the functions to these different machines, and the function gets executed in each of those tasks. Okay, so the functional programming feature, blending the functional programming feature into object-oriented programming features makes Scala a very powerful way to build distributed processing applications. Okay, how it does, we are going to see that in depth in our session. Okay, so at a very top level, Scala basically blends functional programming features with um, with the object-oriented programming features, right? And not only that, so Scala is a pure object-oriented programming language, right? So unlike Java, Scala doesn't have any primitives at all. So even a data type that you declare is basically an object. Okay, so in purest terms, it's a pure, or in strictest terms, it's a pure object-oriented programming language. So everything is an object in Scala. Okay, so a data type is an object. Even a null is basically an object. Okay, so it's a pure object-oriented programming language. It has a mixed paradigm of object-oriented programming style along with the functional programming style, right? And by blending these, okay, it makes it very easy for the programmers and make them very productive and basically able to write very small set of code. Okay, and not only that, it is aimed at basically creating patterns in a very, very elegant and a type-safe way. Okay, so we'll look at various features of Scala, which makes it makes all of this possible. Okay, now and it provides natural support. Like say, unlike Java, see Java was constructed before this distributed processing came into picture, right? So unlike that, so here there is a natural support for providing for performing distributed processing. So although and also Scala, like Spark, it doesn't reinvent the wheel. Okay, so Scala leverages on the Java technology stack, as in it runs on the Java virtual machine, right? So the Scala application also runs on Java virtual machine, just like a Java program. However, the bytecode which a Scala compiles the Scala program into, okay, is much faster than the bytecode created by a Java compiler for a Java program that would run on a Java virtual machine. So in other words, although Scala executes itself on the Java virtual machine, the code that is written in Scala is faster than the Java code running on Java virtual machine itself, right? So that is the greatest advantage of Scala. So, and also a lot of the features which are implemented through RDDs and things like that. Now all of them are direct result of using Scala. Okay, so that is the reason why Scala is very powerful when it comes to building distributed processing, and especially the real-time processing and so on, right? So let's look at Scala in depth in today's session. Now, so Scala is is very rich in terms of, in the sense, like today if you are looking at the third generation frameworks like Spark or Scalding, Akka, Play, Flink, Kafka, so all these are basically written using Scala. So if you learn the Scala language, you can basically use any of these APIs, right? So if you want to build some web-based applications, you can use Play. If you want to build some real-time analytics kind of thing applications, you can use Flink, or like stream processing. Analytics, you can use Spark itself, right? And Kafka is basically a message queue, distributed message queue, again built using Scala, right? So that's the reason, if you were to be in the technology domain, at least for the next 10-15 years, this is the language of choice, and makes you very highly relevant. So that's the reason we are going to spend some time on understanding Scala language. Okay. Now, in our previous session, we installed Spark, and I said that we had a look at the Spark shell, right? So now, if I start the Spark shell, let me get, yeah. So now you can see that what you see here is basically a Scala prompt. So this is what we call as a Scala REPL, right? So a Scala REPL is just a short form for just saying it reads, evaluates, prints, and then keeps looping, right? So you can basically give any Scala expression, okay, and it compiles this expression into a Scala into the bytecode. It executes that expression and gets you the result, okay, and displays the result, and it waits for the next expression, right? So for all your practice, you can actually use this REPL, right? So you can write any kind of Scala code. I'll just, for example, say, okay, 1 plus 1, right? And I hit enter, okay? Now this is a perfectly valid Scala code, okay? So if you see the result here, it says result 0. Now here, everything in Scala is an object, okay? So basically when I gave an expression here, it processed that expression and it executed it and it showed the result, and it's now waiting for the next expression, right? So that's why this is called as a REPL, right? So, and if you see here, the result is also an object, and that object is of type integer. Okay, so I did not specify what it is, right? So I did not specify, I did not assign like in Java. If I were to do the same thing, what do? You said like you have to declare a variable called as integer, and you have to assign that with 1, and then like you have to create another variable, or like maybe you can just add those two together and then store them somewhere, right? So whereas I mean here the Scala compiler automatically assigns the data type. Okay, so the result of this, so it sees this as the Scala compiler determines this as an integer. Okay, so there's an automatic type inference. Okay, there's an automatic type inference. So it infers the data type, and then so you don't have to explicitly declare that, and then it shows that the result is basically an object of type integer, and that is equal to 2, whose value is equal to 2. Let's quickly start working in Scala language, because in Spark anyway you have to write something in Scala, right? So let me see, I generally follow this approach whenever I'm trying to learn a new programming paradigm or a new programming language. Okay, so the first thing that you should look at is how is the data represented in a new programming language, okay? And what is the, what is the abstraction that the language is trying to create, or how is the data represented, okay? And what are the kind of structures that is supported, in the language, right? So that's how you try to, look at the big picture first, and then look at the nitty-gritties of the syntaxes, right? So that makes it much easier to, sort of align our thoughts when we are trying to learn a new language. Okay. So now let's look at, how the variable, how the data is, treated in Scala, right? Now, in Scala, Scala language allows you to decide whether a variable that you're declaring is immutable or mutable. Immutable means cannot change a value, right? So a string is not a immutable data type, Ritu. So a string can be changed, right? So when you say something is immutable, that means it cannot be changed. Okay. Can you think of a structure in Java where you have data not being able to change. So if you think of, like, say, for example, const, right? So if you declare something as a constant, right? So there you cannot change the data, right? So even yeah, final, right? So in Scala, the compiler or the Scala language allows you to decide whether a variable is an immutable type or a mutable type. Okay, so we have two ways to basically create the type. For example, um, I'll use something called as a val here, right? So I'll declare a variable called val, and I'll say val message is equal to, okay, hello world. Okay, so observe what happens now. Okay, so if you notice here, what Scala is telling us, so now you have created a variable called as message, okay, MSG, okay, which is of type string here. If you notice the earlier example, here it was of type integer, okay, whereas here it is showing it is of type string here, okay, and whose value is whatever I've assigned here, hello world, right? So here I did not name any of the variable here, so basically the result was basically an object which is of type integer, and it was assigned with whatever the expression, whatever the result of this expression. And here, if you notice it, I'm explicitly specifying a name of the variable here. And so, and since I was assigning a string into this, so the value that was assigned to this variable is the string that I assigned. Okay, so two concepts that you can notice here. One is so whatever the expression you provide, so that basically results into an object. Okay, and the second thing is automatic type inference, right? So when it is computing, so the data type is assigned based on what value will this particular expression result into. Okay, so based on that, the compiler determines the data type. So you don't have to worry about data mismatch and things like that, okay, which is a very common thing in Java, right? So here, compiler is determining this, so type inference, right? And now this val, okay, so val is a keyword which will make this variable an immutable data type. Okay, so which means once I have assigned something, so suppose if I try to say message equal to something else, right? Right. So now, if you observe, it says reassignment to a val. Okay, so it is not allowing you to reassign once you assign something into a val. Okay, so val is an immutable data type. So if you try to assign something into it, it gives you an error, right? However, so you can say this. So val MSG equal to, like, say, I'll say good morning, right? So this is perfectly fine because now you are recreating this whole MSG. So the point I was trying to make here is val is a structure, val is a keyword which is going to make a variable as a immutable data type, right? So when you say val, if you try to assign some other value to it, okay, now it's going to give you an error. However, now I'm recreating this, right? So I'm recreating this same val MSG, and I'm assigning something else. So now I have this as a different value. Okay. Now I also mentioned that the variable can also be declared as a mutable type. Okay, so mutable type are declared using a keyword called var. Okay, so if I were to write the same thing, so if I say var msg equal to say hello world. Okay, so now you have this as whatever the value that I have assigned it. Okay, so now if I were to reassign this, if I were to say msg equal to good morning. Okay, so now you will notice here that I am able to reassign this. So in other words, with using val, you create a immutable data type. So in immutable data type, it is a read-only data type. Okay, only the first time when you're creating, you can assign some value. Once a value is assigned, you cannot change that value. Okay, and when you use var, you are actually creating a mutable data type, and mutable data type can be both done read as well as write. Right, you can perform both read and write operations. So in Scala, okay, since Scala is used, in Spark, you're primarily dealing with analytical processes, right? And similarly, even in Scala, okay, by default, you always try to create a immutable data type. Okay, so the good practice is to always use immutable data type. Most of the time we will use val. Only when you are required, only when it is required, you try to create vars. So otherwise, the practice is to use vals wherever possible, right? Because in a distributed processing, it always makes sense to keep or in analytical processing, not distributed, in analytical processing, it makes sense to keep the data as immutable because the big data by default is immutable in nature. Okay, so you also noticed the automatic type inference, right? So it tries to identify the type and then it assigns the data type based on the value that is being assigned to this particular variable. Okay. Now, once a type is assigned to a variable, okay, it remains the same for the entire scope of this program. Okay, or entire scope of that variable. Okay, so therefore Scala is called as a statically typed language. Okay, so unlike languages like C++, okay, so here you cannot change the data type of the variables once it is created. So Scala is a statically typed language, and that actually helps in solving a lot of runtime problems. Okay. Now, see, I'm trying to highlight here the key concepts, which are essential for Spark. Okay, so I may not be doing a whole lot of going, every minute details. In a sense, like Scala is very sort of programmer friendly, right? And most of it syntaxes are pretty much the same as that of Java or C++. Okay, so I'm highlighting those aspects which are very relevant for Spark. How is a block of code represented in Scala or C++? In Scala, whatever you put within those curly braces, okay, is a block of expressions, okay, and when you process a block of expression, the result is also an expression. Okay, say for example, now I can say val x, okay, is equal to, okay, so I can basically assign a block of expressions into this variable, right? So I can say within this I create a block, okay, where I'll say within this block, I'll say val A is equal to 10, okay, and val B is equal to 100, okay, and B minus A, okay. So you can notice here, I'm basically creating a block of expression using this curly braces, okay, and the result of this is assigned to this particular variable, right? And if you notice here, I used, sorry, not this. This is, okay. I'm using the semicolons. Okay, semicolons are optional. Okay, so if you're trying to put multiple lines within the one expression itself, then you can, use the semicolons. Otherwise, if you notice here, I'm not using any semicolons. Okay, so semicolons are optional in Scala. Okay, so this is something. So a lot of people say Scala is Java without semicolons. Okay, so it is as simple as that. So semicolons are actually optional in Scala. Okay, here you want to differentiate between the lines, so therefore you have to use semicolons. So if I hit enter now, observe I get the result is x, which is of type integer, okay, which is nothing but the result of this expression. Okay, now what else can you see in this this line? Okay, so wearing a programmer's hat, what else can you see in this line, in this expression? When you're assigning an expression, when you're assigning a block of expression to a variable, right? So can you think of this as like basically assigning an anonymous function to a variable? Okay, so when you think of this block of expression, now don't you think like this is like a function, okay, except that this function doesn't have a name, right? So the way in which Scala looks at it is, so basically when by using this block, okay, so this block actually becomes an anonymous function, okay, and since Scala supports, I'm going to have a an entire session focused on the functional programming features exclusively, right? So where I'll be talking about all those aspects. I'll show you about all those aspects in our next session. But now what you see here is nothing but like this curly braces or this block simply creates an anonymous function. Compiler treats it as an anonymous function, and it is assigning that anonymous function to this to this variable. The result of the this anonymous function to this variable. Okay, now let me show you another important feature, or rather a feature which you'll notice later in Spark. Okay, now let's think about say for example I want to read a file. Okay, so I will say val file is equal to, okay, I want to read data from some text file, okay, or rather I'll read a file and store that as a string, okay. So I'll use the Scala language input output. So there is a source dot, so there is a function called as from file, okay, in this scala.io.source library. there's a function called as from file. Okay, so I'm going to take this function. I'm going to invoke this function. I'll give the name of this some file. Okay, so let's say I'll say data file. That's the name of a file that I want to read from. Okay, now and I'm going to see this is a Scala code. Okay, I'm just trying to typically the way you find Scala code. So I'm going to say call the from file function, and whatever the data that it is loading, basically this is to read the file. Okay, and whatever the data that it is read, I am going to call another function called as make string. Okay, which is going to convert the file contents into a string. Whatever the file it is reading, okay, I'm converting that output, okay, whatever the output of this from file into, I'm basically calling another function on that output called make string. Okay, so make string converts the contents of this file when as it is read into a string. Okay, and I'm assigning this into a variable called as file. So this file basically, my expectation is to read the data from this data file and convert that into a string and store it into this variable called as file. Now, what would happen? So, suppose if I try to execute this, what is the expectation here? Would this work? Okay, so let me try this and see what happens. Okay, so now if you notice here, this is giving me a whole host of errors here. Okay, so it says here Java IO file not found exception. Okay, so is make string a method? Yes, it is a method. Okay, now here so many things that you can infer from this. Okay, so first of all, if you observe, this make string is a method. Okay, is a method which is part of the Scala language itself, right? Scala functions. Now you don't need those brackets to invoke those message, right? So typically in Java you use those brackets, right? Open and close brackets. So you don't need that. That is optional, right? So without that also you can call a function. Okay. And another thing you notice is, so it is giving me an error, and what is the error? File not found exception. So the data file, what I'm giving here, so the system cannot find the file specified. Okay, so there was no file, so therefore this one gave me an error. Right? Now, let me do it another way. So in Scala, there is a concept where you can define a value as lazy. Okay, so Scala by default allows you to support, like, see, one feature that you saw what Scala did was type inference. It was automatically determining the data type of a variable based on which value is going to be associated or attached to that particular variable. Now similarly, there is the concept where you can declare a variable as lazy in Scala. Okay, so when you declare a variable as lazy in Scala, what actually happens is the compiler will execute that expression, okay, whatever the expression that you are assigning to that variable, but it will not evaluate that expression. Okay, now this is very, very important. Now, the reason it will not evaluate this expression will come in handy, especially when you're doing the distributed processing applications, right? So, by using the keyword lazy, you are deferring the evaluation of the expression. It executes it in the sense that if there are any compiler errors, it will detect it when it is executing itself, but it will not evaluate that expression until there is an actual use of the data somewhere within your code. For example, I'm going to rewrite this code. So now I was just trying to write this program. Okay, I don't have this file, but I don't want to get into all this, like, trying to create this data file and, assigning the path and all that, right? So I just want to get started right now. So I will just rewrite this code. I'll use up arrow to basically get back to the, the previously executed command. Okay, so now I'm going to declare this as a lazy fellow. Where is this? Sorry. So supposing if I declare this as lazy, okay, now observe here. Okay, so when I execute this, it did execute it. It did not give me any error. Okay, so what is here actually happening is, see, if you observe here, it has created a variable of type file, which with a name file, and it has determined that the data type is a string because I'm using, I'm assigning the output of this make string function into this variable, right? So you have a variable called as file, which is of type string, and notice it when we are looking for the value, it says it is lazy. It has not yet computed the value of it. Okay, so this is called as lazy evaluation. So Scala language itself supports lazy evaluation, right? So now your program works fine until the point when this file variable is actually used, right? So till then it actually defers the evaluation, right? So this way you can declare something as lazy so that internally it waits until there is a use for that. So if supposing somewhere in your code you're using this file file variable, and at that point of time the data is not present, then it will fail. Okay, so this lazy evaluation approach is used extensively when it comes to the Spark functions, right? So in the Spark API, it uses the lazy evaluation approach. Is this clear? So lazy keyword is delaying the the evaluation of expressions. This is very useful for delaying the initialization process and things like that, right? So, but internally, Spark uses that heavily because RDDs are immutable data structures, right? So RDDs are basically immutable data structures, and if you are trying to do some processing on it, okay, then it is always creating a new, copies of the data, right? So therefore, it defers the evaluation so that the compiler can internally optimize, the number of multiple copies it can make. Okay, so that I'll come back to it later. But the point I was trying to highlight here is, if you use lazy keyword, so the evaluation of an expression is delayed, and that evaluation occurs once this variable is used somewhere. Okay, so if I tell you to say, if I say println of file, I want to see what is there in this, what are the contents of this file. So now at this point of time, you are explicitly doing some action on the contents of that file variable, right? So at this point of time, so then it gives me the error, right? So here you can see that, that data is not found.